Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 6. Well, we're gonna break this down one step at a time. We're gonna solve these katas, you and I. Gonna break this down one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah. Welcome to the show. You may notice my desk and camera's in a different area. I'm just trying it out. If you're watching live, let me know if I'm in the way of the code or anything like that. I'm gonna do my best to not be cool. But if you've never been to the show before, I solve code katas live in front of you. And I do have a GitHub repo where I post the code that I write every time. And if you have any suggestions for katas for me to solve, you can add a comment to this issue. I didn't get any new comments, so I went ahead and picked a few. But if you go to this repo, all of the katas that I'm going to be doing tonight are linked to there, so you can give them a try as well. If you're watching live, say hello, throw a message in the chat, and I think we can go ahead and get started. Let's get started on this very first one. Actually, I'll kind of introduce each of them, and then we'll get started. They're in order of increasing difficulty. So the first one is called Beginner Series number 3, Sum of Numbers. This is a 7Q. Find the odd int. It's a 6Q. Sum of digits, or the digital root. That's a 6Q. Dubstep is a 6Q. Moving zeros to the end is a 5Q. And then calculating with functions. This one seems super interesting. It's a 5Q, and then we'll end with a reverse Polish notation calculator, which is a 4Q. These are a little bit more challenging than what I've done in the past, but we'll see what we can do. James, welcome to the stream. Hello. Okay, let's get started with this very first one. So this one is called Sum of Numbers. So given two integers, a and b, which can be positive or negative, find the sum of all the numbers between them, including them two, and return it. If the two numbers equal, return a or b. Note a and b are not ordered. So for example, if you're given 1 and 0, you sum up all the numbers between 1 and 0, you get 1. If you're given 1 and 2, you sum up all the numbers, you get 3. I think you get the idea. So let's give it a try. Whoa. Okay, so we'll throw our examples up there. Okay, and they tell us that we don't know which one is going to be larger, A or B. So here's what I'm thinking. The first thing we need to do is find the lowest of A and B. So find lowest of A and B, and find highest of A and B. So once we know which one is lower and which one is higher, we can just write a simple for loop that goes from one to the other. So we will iterate from the lowest to the highest. We'll also need a place to store the sum. And we will, inside of this iteration, add the current index to the sum. And then lastly, we will return the sum. So not too difficult, but let's give it a try. So there are a few different ways I could try to find the lowest of A and B. Let's do it the long way first, and then I'll show kind of a built-in way we can do it. So we are finding the lowest, but I'm going to call this beginning, because this is where we're beginning the loop. So let's say say if A is less than B, then, and we need a variable, so let's say begin starts it off there, starts off as nothing. If A is less than B, then we want begin to be A. Else begin will be B. And then we also need a variable for end, so beginning and ending. And if begin is A, then that means end will be B. And if begin is B, then that means end will be A. Cool. So that's kind of like a manual way to do it. After we solve this, I'll show how we can maybe use a built-in method to figure that out. Okay, so we know where we need to start. We know where we need to end. Now we need a variable to store the sum. So let's say let sum start it off at 0. So that's that. And then we need to iterate from the lowest to the highest, or from the begin to the end. So let's write a for loop. So we'll say for let I equal, and we're going to start I at begin, while I is less than or equal to end, because we the description said we want to add both of the numbers inclusive. So while I is less than or equal to end, increment I each time. So that's our loop. This formatting is way off. I might have to bring this down locally. Okay, but so we're iterating from the beginning to the end. Now we just need to add the current index onto sum. So sum plus equal I, and that should do it. Return the sum. Let's see what we get. Sample tests. It passes. Test a little bit more. Cool. It's looking good. Emmy, welcome to the stream. Hello. All right, yeah, so pretty basic stuff. Let's bring this down and see if we can make it a little bit cleaner or use some built-in methods. So this is called sum of numbers. Cool. All right, so this works, but let me show you what I was talking about in terms of like finding the higher or the lower one. So we could use math.min and math.max. So if I say math.min of a and b, that will give me the lower one. And if I do math.max of a and b, that will give me the higher one. And if they're both equal, then beginning will be equal to end. Cool. So we have a place to store the sum, and there's not much else I think we can do here because we're not iterating an array or anything like that, so we can't really use a reduce. We could though. So let me just try this out. This will work, and then I'll show like a trick where we can create an empty array and then for each over that using its index. Let's see. Console.log, and this should be a console.log. Okay, so if we run this file, we should see -1 and 1. Let's go into today's directory. Yeah, so that's working. Yeah, let's try this though. So if I do, I think here's what we can do. We can say new array, and you can give it a length. So the length we want is end plus 1, because we want the index to go all the way, I think. Well, I don't know. The length we want is n. Let's say fill it with zeros, and then we will try to reduce this. Let's take a quick stretch. So yeah, I believe when we create, let's look at the MDN docs for this. And mainly the idea is I want to be able to use a higher order function like reduce instead of just a for loop. So if I create an empty array and then reduce that to the sum, it could happen. So let's look for array on MDN. Glossary, global objects. And is there anywhere where we're doing new array? Yeah, so you can pass in the array length. And I think I want it to be end, and then we want to fill it with 0 so it actually has values inside of it. And then we'll try to do a reduce. We're reducing the sum. We have the value, and then we have the index. Wait, is this going to work? This isn't going to work because I need the first index to start at beginning, I mean. I think we can, let's figure it out. We can make this happen. It'll get weird. We'll make it happen though. So because we're reducing, we're going to start that off at 0. and I want to be able to return this whole thing. This is what we want to do inside of the reduce. We want to add the current index. Whoa. Index. But that's going to start off at 0, and we want to start at beginning instead. So if we add begin to it, it should start where we want. And then the array is end length, so it should end where we want. I don't know. Let's see what we get. 0, -1. So I think we need to go to end +1 because we need the index to be one more. Nope, that broke. Okay. Let's see if this actually gives me what I want, though. Am I actually getting an array filled with that many zeros? Let's log it. So this one should have, oh, no, the length is going to be begin minus end. Sorry, end minus beginning, and the absolute value of that. Because end, it could start with a negative number. Okay, so this is what, so the length of the array should be end minus beginning, and we want to take the absolute value of this, meaning make it positive. Okay. And we want to add 1 to it because we want it to be that long. Okay, so we get an array of length 2. This is now what we want, filled with zeros. And so now we should be able to reduce that. Okay. And let's see what happens. Undefined. Oh, we need to return the sum. Here, we'll return sum plus index plus the beginning. Hey, -1 and 1. Let's try it out. This is like really hacky. We're like creating a whole new array just so that we can use reduce. That's okay though. Let's see if this will work on Code Wars. Sample tests. It works. Attempt. It works. Cool. I personally like. It's cool that we can do that, but I'm gonna submit my other one. Emmy says she is afraid of reduce. I wouldn't be afraid with it. I would probably start with like, how would you write that code with just a for loop? Because you can write the same code with the for loop, but then getting used to seeing like what's happening. Like, because before we started our sum at 0, so with reduce our sum starts at 0, and then I'm doing this interesting thing here, but really what you could think about is sum is going to be the rolling sum every time. And typically you want to return sum, but I just did it all in one line, but you could say sum plus equals. So in the example of like reducing to a sum, you do inside of there what you were doing inside of the for loop. Obviously here it's slightly modified because I had to change some things. But then the last thing you do in the reduce is return the sum. It does take some getting used to, but I'd say don't be afraid of it. Use it. The more you use it, the more you can get used to it. Okay, yeah, I'm gonna submit this one just because that array thing is really wonky. Attempt. Submit final. Let me pull up my soundboard. Soundboard. Ah, that's so loud. I apologize. I apologize. Anybody that had headphones in, I am so sorry. Okay. We did it. And those of you watching live, is my camera position okay? Can you hear me okay? Is everything okay? Let me know if there's any issues, because I'm trying this thing out. And look at this, full CJ all around. Okay, yeah, so that was great. Let's move on to the next one. This one is a 6Q. Find the odd int. So given an array, find the int that appears an odd number of times. there will always be only one integer that appears an odd number of times. Cool. And so if we look at the examples, they're just passing in a big array of numbers, and we need to tell it which number occurs an odd number of times. Cool. All right. Thanks. They're saying that I'm clear and good. All right. Let's look at like this example. So in this example, the number 5 appears 1, 2, 3 times. And every other number appears apparently an even number of times. So after going through the array, we found out that 5 appeared an odd number of times. So here's what I think we need to do. We need to build up and keep track of the counts of everything. And then once we've counted everything in the array, find the first one that's odd and return that. So here's what we'll do. We'll have a place to store the counts. We will iterate over the array. And if we have not seen this number before, so if we haven't seen it before, then we will add it to counts with a value of 1. And then if we have seen this number before, increment its count. Okay, so that will count everything in the array. Once we've counted everything, we need to figure out which one was odd. Okay, so now we will iterate over the counts. If the count is odd, return that number. And the moment we find an odd count, we can return it because it says only one thing will have an odd number of things inside of it. Okay, let's give it a try. So for a place to store the counts, this is going to be an object. And the idea here is we'll have like 20, and that showed up 2 times. And 1, and that showed up 4 times. And 5, that showed up 3 times. So we're going to build up this object to look like that, because once we have it, we can figure out which one has an odd count. So we'll start it off as empty, and then we will iterate over the array. I'm going to rename this to array. So let's iterate over the array. And actually, we could use reduce. I'm going to write it with a for loop first, and then I'll show you how we could reduce the array to this object of counts. But let's write it with a for loop. So let I equal 0 while I is less than array.length I++. And then we're going to do all of this goodness here. So if we have seen this number before, so the way we can check that is we'll say if counts at, and let's just create a variable for the current number. So let's say number is array at index I. So we're going to pluck out that specific number from the array, and we'll say if counts has a value at number. So if it doesn't have a value at number, then we will add it. So we'll say counts at number equals 1. So we're going to add it and give it the value 1. Else, that means we have seen it before. So we're just going to simply increment the count there. So I'm going to say counts at number ++. And this is just a way to see if an object has a given key or a given property. You can say not that property, because if it's not in there, this will be undefined. Not undefined is true, so that will go into this if statement. So at this point, we've built up the object. Now we need to iterate over it. Multiple ways we can do this. We could do like an object.keys and then map it. I'm going to use a for in loop. I think that will work. Let's look up, actually, I always get confused between the for in and the for of loop. I think for in will give us access to each key in the object. Yeah, so if you do a for in on an object, you're going to get the property names, like in this case, A, B, and C. And in my case, the property names are going to be the actual number that has the given count. So I'm going to use a for in loop. And so we'll iterate. So we'll say for const number in counts And then the count is going to be counts at that number. So we'll reach in and grab its specific count. If the count is odd, so if count mod 2 does not equal 0. So you may have tried to check to see if a number is even before. You can use modulo 2. So if a number is evenly divisible by 2, then that means that it's even. So we're checking if it's not evenly divisible by 2, then we know that it's odd. And then we will return that number. So in this case, we will return a number. And let's see if there's any special case where we would need to return 0. Yeah, so I guess I'm even just going to get rid of that return statement, because this for loop, the moment it finds it, it should return it. Let's see what happens. Okay, so notice, so it's saying expected 5 instead got quote 5. Expected -1 instead got quote -1. So one thing about adding it as a property in an object, when you use for in, the property is actually a string. So before we return it, we want to turn it back into a number, because at this point, number is a property in the object. So let's return it as a number. Lots of different ways to do it. You can use the number constructor. That will return a number. Cool. A neat little trick is if you just put a plus sign in front of it, that coerces it to a number, and that will actually return a number. So if we do that, oh no, sample tests, that works. Cool. All right, let's bring this down and write it some other ways. So this is odd int. Okay. So I do want to write this with a, well, the first for loop, let's write this with a reduce, because notice we are taking this array of values and reducing it down to this object. Like the point of the code inside of the for loop is to create this object. So we can definitely do this with a reduce. So we'll say counts equals array.reduce. We're going to have some function. We are creating the counts, so that can be our accumulator. And then the thing we need on each iteration is the number. And then the second parameter to reduce is where do you want to start this accumulator? And we want to start this as an empty object because that's what we're building up. So start as an empty object, and then inside of the reduce, we're going to be setting properties on it. And so now I'm pretty sure I can just take this code from inside the for loop and put it in my reduce. Cool. And really the main thing you have to remember with the reduce is to return your accumulator value, because then we're returning the object every time. And this should do it. Let's test it real quick. What's our function called? Find odd. And we actually want to take a quick break. Okay, so actually, we want to console.log the invocation of find odd with, is that gonna work? This is getting weird. I gotta fix some things. Because basically I want to invoke it, get the return value, and then compare it with some other value. Yeah, that should do it. Let's try to run it. Cool, so that's working. We're getting back the values that we expect. Yeah, and this is a classic example of like taking something that's not a reduce and turning it into a reduce. Literally the only thing we had to do was return counts inside of there. We simply just copied and pasted the code inside of the reduce, and it worked exactly the same way. I also want to show a shorter way to write this. So this is checking, okay, if counts doesn't have that property, then let's set it equal to 1. but we can shorthand that. So what we can say is counts at number equals counts at number. So if it's already in there, then just set it equal to itself, or start it off at 0. And then right below that, we can just do counts plus plus. And so what this will do is if that number is not in the object, it will add it in there and initialize the count to 0, and then we'll increment it. If the count was already in there, we'll just increment that existing count. So that should do the same thing. Let's try it. Awesome. I wonder if there's a way we can make this for in a little bit shorter. Okay. I'm thinking we could potentially use a maybe like a find index, because I think does find index let you pass in like a function to check for that value? Because we could use find index on the keys with this case, like if its count is not divisible by 2. Let's see. Yes. So in this example, they're passing in a function to find index, and it returns the index of the first element that matches that specific case. So I think we can use this. So let's say we do this. Let's say, oh wait, do we want the index though? I guess it could work. Let's make it work. So if I say object.keys with counts, that's going to give me all of the properties from counts. So let's say numbers equals that. And then I want to find the index. So we'll say odd index is going to be numbers dot find index, and we're going to get the number, and we just want to return really this part right here. So we want to return that because return. So we're saying, okay, numbers is an array with all of the properties, and I want you to find the index where that number, and then we actually grab the count out of the object and see if the count is not divisible by 2. So this will give us the first index in this array of properties where its count is odd. So that grabs that. And then the thing we want to return is numbers at that odd index, because that's this is actually going to be the odd number. The number, because numbers are just the properties, so that's the odd number. And then the actual actually, yeah, that's the one we want then. We want to return that specific number. Yeah, so then we'll just return, numbers at the odd index, and we still need to parse it as a number. Let's see what happens. It works. Cool. I am proud of this solution. So we first build up the counts. We then grab off all of the properties, and let's just log this out so you can see kind of what's happening here. Because numbers are essentially the unique numbers that we found inside of the array, because that object is only going to have them occur once each time. And then if we log the odd index, this is the index where that specific number has an odd count. So let's check it out. So notice numbers is an array where all of the unique numbers from the array are in there, because those were the keys on the counts object. And then the index of the odd one is 4, which would be 0, 1, 2, 3, 4, that value, and we return 5. It works. Cool. Yeah. I'm trying to think how we could make this even smaller or use different things. I don't know. I think I'll just submit this one. I will mention though, the thing I like about find index is, unlike for each or map or filter, find index will immediately stop iterating the array the moment it finds something that matches. So believe, yeah. And so this is slightly more performant because it's almost like a for loop that you can break out of. So that's pretty cool. Let's submit this one. Sample tests. It works. Attempt. It works. Submit final. All right, drum roll, please. Or awesome. Okay, that was fun. Moving right along. Sum of digits or digital root. Okay. In this kata, you must create a digital root function. A digital root is the recursive sum of all the digits in a number. Given in, take the sum of the digits in. If that value has 2 digits, continue reducing in this way until a single digit number is produced. This is only applicable to the natural numbers. I think that means positive numbers. Here's how it works. Okay. So for example, if you're trying to calculate the digital root of the value 16, that is more than 1 digit. So you add its digits 1 and 6, you get 7. That's a single digit, so you return it. For 942, it's more than 1 digit. You add 9, 4, and 2. You get 15. I don't know what this is about. Maybe that's like Ruby syntax or something. I don't know. And then 15 is more than 1 digit, so you add 1 and 5, and then you get 1 digit. So essentially, we're adding all of the digits inside of that number continually until we get down to a single digit. Okay, let's copy an example like this one, and then we'll give it a try. Okay. First, we really need to check, is the number greater than 9? Because if it's greater than 9, that means it's 2 digits. So check if greater than 9, then do something. Otherwise, return in. Because if it's not greater than 9, then we know that it's a single digit and we can just return it. Okay, if it's not greater than 9, then we will sum digits and reassign to in. And then we'll check it again. So let's say, instead of check, we'll do while. While in is greater than 9, sum the digits, reassign sum to in, and repeat. Okay. How are we going to sum the digits? We could use, there's a few different things we could do. First, we could like turn this into a string and then reduce it by adding up all of the values as numbers. We could also use math though. So we could mod this number by 10, which would give us the last digit, and then divide the number by 10 and drop the decimal to drop off that digit. So we could do that over and over again to grab each of the digits and add them together. So that's what I'll do it that way, like the math way, and then I'll show how you might do it with like a built-in like string split reduce or something like that. So first you will mod the number by 10 to get last digit, and then take math.floor of number divided by 10 to drop off last digit. And we really need place to store the sum, drop off the last digit, and then add last digit to sum, and then repeat. So we really need to do all 3 of these lines while the number is greater than 0, because we're going to be dividing it by 10 until it gets down to 0. So we'll say while n is greater than 0, do these 3 things over and over, and eventually you'll get the sum. And then once we have the sum, we will reassign it. Okay, let's try it. I am going to pull this down locally just because I can't scroll any further, so I want to scroll down. Let's call this digital root. Okay. Oh no, get rid of. Okay, I was about to say get rid of my formatting. Yeah, and I like code because I can scroll like that. Okay, so while n is greater than 9, easy enough. So while n is greater than 9, do this stuff. Otherwise, return n, because if n was 9 or less, we know it's a single digit, so that is the digital root. Okay, sum the digits. So really this be there. So a place to store the sum. So let's say let sum, initialize that as 0, and then while n is greater than 0, do these things. Mod the number by 10 to get the last digit. So let's say const last digit is going to be n mod 10. So that's 10. This is the remainder of division after dividing by 10. So that will give us the last digit of the number. And then take math.floor of the number divided by 10 to drop off the last digit. So we'll say n is equal to math.floor of n divided by 10. So that will drop off the last digit. We will add the last digit to sum. So we'll say sum plus equals last digit. And then we'll repeat this until n is down to 0, meaning we have added all of the digits inside of that number. And then we'll reassign sum to n. So then we'll say n is equal to that sum. And then repeat, because if the total sum is still greater than 9, we need to do this again. All right, let's pull down some tests to try it locally. Well, that's not helpful, but let's try it. Okay, so the digital root of 16 should be 7, so we should just see 7 log to the console. It works. Let's try it with some of their other examples, like this one. So the digital root of this number should be 6. 6. I'm surprised that works so quickly. Okay, awesome. So we've done it. Let's try it on CodeWars and see if it accepts it. Yeah, and then after we do that, I'm going to show, basically we can do this without math. We could like turn it into a string, split it into an array, reduce it to a sum, and then check to see if that is greater than 9. Yeah, but let's see if this works. Sample tests. Yes. More tests. Yes. Awesome. All right, let's do it the JavaScript way. Okay. Yeah, we still want to do while the number is greater than 9, but this whole piece of code right here is to sum up the number. But let's say we do this. We could say in.toString. So that takes a number and turns it into a string. Once it's a string, we could then split it into an array. So split on the empty string, and then we can reduce that. So that's going to give us the that's going to give us the sum and the number, each digit, and we want to return sum plus digit. and we want to start this reduce off at 0. So we'll say well, really we can just say in equals that. And because we turned it into a string, we do want to make sure that the digit gets turned into a number, so we can do that. So that, I think we'll do it. So like say for example, in is this number. Then when we toString it, we're going to get that number. Then when we split it, we're going to get an array with each of those numbers as strings inside of it. Like that, like that, like that. I didn't have to do this whole thing. I guess I will though. Gone far enough. Okay, so we start with this number. We then toString it, which gives us this. We then split it, which gives us this. We then reduce that to a number, to a sum, and that should do it. Let's try it. Well, not that. It works. Cool. Let's try it out on CodeWars. Simple tests. Attempt. That worked too. Cool. Can't think of too many other ways. Let me see how long I've been streaming. Cool. I am going to just submit this the way I have it. I'm going to use my mathy version, mainly because like this is a lot of extra work. Like turn it to a string, split it, reduce it. It's a lot of iteration. Whereas this is just some simple mathematic calculations. So I'll use this one. Attempt. Submit final, drum roll, please. Oh, no, wrong one, no. No, stop it. Snare. It worked. Cool. Look at this. That is very simple. It looks like this person did kind of what we did. So if it was less, if the number was less than, oh, they did it recursively. So if the number is less than 10, just return it. I had while it was less than 9, we need to like add up all the numbers. And then they just did this thing. So string it, split it, reduce it. This is super interesting. Let's Google digital root, because that to me just looks like some sort of mathematical formula. Like number minus 1 mod 9 plus 1. Like that's what? Digital root formula. Wikipedia. The digital root, also repeated digital sum of a non-negative integer, is the single digit value obtained by an iterative process. Okay. Significance and formula of the digital root. Okay, so this is a formula. 9 minus n, n minus 9 times the floor of n minus 1 divided by 9. Is that what they did? N minus 9? No. Formal definition. Proof that the constant value exists. Congruence formula. This looks like what they did. Can I copy that? Let's compare it. Wait, can we see that? So they did n minus 1 mod 9 plus 1. Cool. We should have just looked it up. It was fun to break down a number though. Any other cool solutions? Yeah, recursive solution, definitely. And it's interesting to note that anything that can be done recursively pretty much can be done with a loop also. Because recursion is a way of doing loops, but on using the stack of a computer. Emmy's right there with me. Yay! Thanks for your support, Emmy. Cool. All right, on to the next one, because we do have a few more to go. All right. Okay, this one's interesting. Dubstep. A lot of backstory. I don't want to read all of that. But for example, you get an input that so a song has the words "I am X," and then in the dubstep remix, it gets transformed into "wub wub I wub am wub wub X," and the rules are that every word will have at least one wub between it, but it may have more than one wub. And you need to decode the song. So you're given the wub wub, and you need to pull out the wubs to get back the actual word. So the input consists of a single non-empty string consisting of only uppercase English letters. Ty says, stopping by to say hi. Appreciate it. Thanks for your support. Okay, return the words of the initial song that you use. So, for example, if you're given this input, wub, we wub are, wub, the wub champions, wub, my wub friend, wub. And that decoded is, we are the champions, my friend. Okay, so basically, we have a string, it's got a bunch of wubs in it. We need to take those wubs out and give back the original thing. Okay, so let's like copy this as an example. All right. No, comment that out. Okay. So, I mean, here's my thought. We could, a few different solutions. One is, like use replace and split and join to, well, first we could actually, no, how about this? So I'll write it out. So split the string on wub. And so if we split it on wub, we're going to get back an array that if there were multiple wubs, then there will be empty slots in the array, but we will pluck out all of the words. So split the string on wub, and then filter out empty strings, and then join back together on space. Simple enough. Let's do it this way, and then we can probably tackle this with a regular expression too. Okay, so we want to split the string, so song.split on wub. Okay, so that's going to give us an array, but there will be some empty values in there. And then we want to filter that word. And there's a built-in thing in JavaScript called trim, which takes off all the space on the sides of a string. So if we trim it and there's nothing in it, we don't want that. But if we trim it and there is something in it, we do want that. So this should return, is that right? Word.trim, not word.trim. So if it's empty, not would be true. We don't want that. Just word.trim. Because if word.trim returns an empty string, then that will be a falsy value and filter won't include that word. Okay, so that filters out the empty strings. And then let's join it back together on a space. Sample tests. Too easy. Okay, attempt. Okay, cool, and we did it. Let me pull this down, and I'll kind of like log out what's happening there to make it make a little bit more sense. This is called Dubstep. Okay, let's store these in variables. So let's say split is string.split. And then let's log out split. And then we'll say words is split.filter. So this is going to pull out all of the words that are empty. And then the result will be words.join on the empty string. and then we'll return that result. Okay, let's run this locally. Log. Wait. Oh no. Redo. Cut. There we go. All right. Is that enough parentheses? I think so. Let's see what we get. Let's run node dubstep. We are the champions, my friend. So when we split on wub, if there... Yeah, I believe if there were multiple wubs, we end up with an empty string in that slot. So, and actually, let's log out words here too. So after we filter it on trim, that is what actually removes all of those empty spaces. So that way, when we join it back together, yeah. So our initial split gives us that. We filter it to get rid of all the empty strings, and then we join it back together on spaces. So that works. Let's try to use a regular expression. Really, we just need that. Okay. So we can use a replace to do a regular expression. What do we want to search for? We want to search for wub and 0 or more occurrences of that across the whole string, and we'll replace that with a space. Yeah, I don't know. Let's see what we get. That seems to work. But are there spaces on the beginning? Yeah, they are. So I think that's the issue. Because there are like wubs at the beginning, this wub gets replaced with a space. So we could regex it and then trim it to remove the spaces on the edges. There we go. I think I'll submit this one. Sample tests. Oh wait, is it taking that long for the sample tests? Attempt. Okay, submit final. Drum roll, please. We did it. Awesome, Kaizen, hey. I did have a great day. Awesome. I'll see you later. Have a good day or night. I think night, right? No, morning? Day. Your day is just starting, I think. But yeah, I'll see you later. Cool. Let's see what other people did. Regular expression solution. So find one or more occurrence of wub, replace it with a space, then trim it. Split on wub. So this is an interesting use of filter. By passing in the Boolean constructor, they're creating... I'll show what that means. So if you may not have known that you can do this, but let me show you. You can create a Boolean. Whoa. When I zoom in, it cuts off my text. That's lame. Okay, but you can create a new Boolean by passing in like a truthy value. So if I pass in an empty string, that gives us a false Boolean. Or if I pass in a string with a space in it, oh, that gives us true. But I guess that's not what's happening though, because when you do a split, you're gonna get back empty strings. So by passing it into Boolean, whenever they pass in an empty string, that has a value of false. But if they pass in like that has a value of true. Very clever solution. And so anything that is true is an actual word, and then join it on a string. And then this one is filter for any word that is not an empty string, and then join it back together. Cool. Moving right along. Okay, this is an interesting one. So this one is write an algorithm that takes an array and moves all of the zeros to the end, preserving the order of the other elements. Okay. Whoa. Whoa. That's not good. Sorry. Hey, Shalom. Welcome to the stream. And okay, so basically we are given an array like this, and we want to take all the zeros and put them at the end so that everything else kind of like fills up those spaces. So where there was a 0, things shift up, and then everything else shifts up, and then the zeros are at the end. Okay. I think the easiest way to do this would be to create a new array. We could iterate over the array, and if something is not a 0, just push it into a new array, and then if something is a 0, have some sort of counter, and then after the iteration, push a bunch of zeros into the end. So basically we're iterating over and only putting new things in another array where things are not zeros. So let's say like this. So place to store the moved zeros array. So we need like some sort of array to store things. We'll iterate over the array. If the current value is not a 0, push into move zeros array. Else increment 0 count. So we need a place to store the 0 count. So essentially we're keeping track of the number of zeros that we saw. And then once we get to the end of the array, we're just going to push that many zeros into the end of the array. So that goes over the whole array, and then iterate up to 0 count and push 0 into the array. And then lastly, we will return the moved zeros array. Cool. Let's give it a try. Okay, so we'll say like moved zeros is an empty array, and then 0 count starts off as 0. We haven't seen any zeros yet, and then we need to iterate over the array. So let's create a for loop. While I equals 0, while I is less than array.length, I plus plus, and then we'll do this. So if the current value is not a 0, so let's just say value is array at I, and if that value is not a 0, so if value not equal to 0, push into the moved zeros array. So we'll say moved zeros dot push value. Okay. Else we will increment the 0 count, because if it is equal to 0, we want to say, hey, we saw a 0, keep track of that. Okay, so at this point, we should have an array that has all of the values in it. Now we just need to push the zeros we saw into the end of it. So let's go from 0. So we'll do a for loop. Let I equal 0, while I is less than 0 count. So we're going to go up to the 0 count, I plus plus, and we will push a 0 into the array. So moved zeros dot push 0. So we're just putting it at the end, and then lastly we will return the array. Let's take a quick stretch. Whew. See that my streaming laptop is working really hard. I'm just going to check on that real quick. I mean, OBS is using 50% CPU. Okay, oh well. Okay, let's give this a try. Sample tests. Array is not defined because it's called R. Is that the only place I used it? Let's try again. Sample tests. Works for sample, full attempt. Cool. All right, let's bring this down. There are a million and other ways we can do this. So let's create a new file. Zeros to the end.js. Okay. So this here, we could turn into a reduce. We're actually reducing down to an array. And we don't want to use a map because this array potentially will be shorter than the input array, and a map will always return an array of the same length. So let's do this. So we want to turn this into a reduce. Let's do this. Moved zeros is going to be array.reduce. And we'll call this, yeah, our accumulator is move zeros, and we get access to the current value. And we want to start our reducer at empty array. And now we can get rid of these. And then we can just move this into our reduce. And we want to return move zeros. I guess the interesting thing here is we do have this zero count kind of just like sitting right outside of the reduce, but that's okay. So we reduced down to an array without the zeros in it, and then, yeah, no other way to iterate up to the zero count to push in those zeros. Actually, can we do array.fill? Let's see. No, we want to search mdn for array fill. Because if we can tell it go from the end up to zero count, we could fill it with zeros. Let's see. The fill method fills all elements of an array from a start index to an end index with a static value. That should work. The end index is not included. I think that should work. So let's say moved zeros dot fill. So we want to pass in the value is 0. We want to start at what index? We want to start at the end of the array. So we'll say move zeros dot length, and we want to go, the end will be the length plus 0 count. Yeah? I don't know if this will work on an array that's already smaller than that. Let's see though. Let's run this locally. Zeros to the end. Oh, we need to log it. No, it didn't work because this is what it's returning, so it has no zeros on the end. What if we did this? What if we pre-sized the array? So here, we know that the array is going to be array.length. So we'll pre-size it. And then here, instead of pushing, then we have to keep track of like the last index we pushed. This is tricky. I want to do this though. Okay, so create an array, pre-size it as the length, and then instead of pushing, we want to say some index. Let's say array index will be equal to that value. And then really, we want to increment the array index. And the reason I don't want to use the built-in index for reduce is because this array will not have the same indices because it's being shifted. I guess we could do index minus the current 0 count. Would that be right? Let's try it. Because if you say index minus 0 count, that will go back in the array to where it should be. And then now we want to fill it from length minus 0 count, because that will be the, well, no. Hey. We could pre-fill it with zeros and then only set the values because then it'll already have zeros in it. Let's see. Okay. So does the array.fill method return the array? Returns the modified array. So if I say fill with 0, and I think that's all we have to do, because we basically start with an array that just has a bunch of zeros in it, and then set the values in it. Will this work? This is cool. Will this work? Let's see. Hey! Hey! Okay, that's awesome. So create an array that is filled with zeros, and it's the length of the input array. And then as we reduce, we're keeping track of every zero that we see, so that way we can set the correct index inside of the move zeros array. So if there are no zeros, then the index inside of the move zeros array is the index that it was inside of array. Great. But if we have seen zeros, then that index has to shift back, so we just subtract 0 count. Yeah, I like this. I don't know about the performance of this. I've read some things that like pre-filling arrays or pre-creating arrays may not be that performant, but this is super interesting. And it makes sense, right? Like, create an array that has zeros in it, set the actual values, and then when you're done, it already has zeros on the end of it. Cool. Let's see if this works. Yeah, attempt. Hey, it worked. Cool. I do have 2 more katas to do. Because one thing is, we are creating a new array, right? What if we did this in place? Like, what if we just took the existing array and then like moved the zeros to the end and like shifted everything up? Should I code it? I'm gonna do it again, but we're gonna do it in place. So instead of creating a whole new array, we are going to use the existing array and just shift the things that are inside of it. Okay, so let's say this. Okay, iterate over the array, and if the current value is a 0, shift all of the values to the right up 1. So if the current value is 0, take everything to the right of it and just shift it over, so that way there's no longer a 0 there. And then we need to okay, so if the current value is a 0, shift all of the values to the right, up 1 to the left. So that's going to shift everything up. And then we need to take that 0 and put it on the end. So let's keep track of the number of zeros we've seen. yeah, so keep track of 0 count. And then we'll say set array at length -1 minus the 0 count to 0. Because if the 0 count is 0, the moment we come across a 0, we're going to want to set the last value of the array as a 0 because we just shifted everything up. Cool. Okay. And I think that will do it with some caveats. I don't know. Return the array. Let's see. All right, let's try it. So we're going to keep track of the 0 count. So let's say 0 count starts at 0. Cool. Iterate over the array. So I equals 0. Well, I is less than array.length. I plus plus. Okay, if the current value is a 0, let's store it in a variable. Say value is array at index I. If that value is equal to a 0, then we need to do this stuff. Oh, and don't forget, increment the 0 count. So now we want to shift all of the values to the right of that 0, up 1, to the left. Okay, so we're going to need another for loop. We need to go from I equals, we'll call it j. Let j equal I. So start where the 0 is. So start where the 0 is. While j is less than array.length, might have to fiddle with that, j plus plus. And to shift it, we'll say array at j equals array at j plus 1. And so actually we want to go to length -1 because we're going to be shifting everything. And so if we found a 0 at index I, when we shift everything, we'll start and say the array at index I, because it starts at j, will be the next value over, and then just repeat all the way to the end. Now we need to put that 0 on the end. So we'll say array at array dot length -1. That would be the end of the array minus the 0 count. Starts off at 0, so we'll set that to 0. So and this is R, not array. So we just shifted everything into where the 0 was, and now we're putting the 0 on the end, and then we increment the number of zeros we've seen. So 0 count plus plus. Cool. Oh, Emmy, see you later. Thanks for tuning in. Oh, it's a const. We need to make it a let. But let's think about this. We actually only want to iterate up to where we've put the zeros, right? Because we don't want to go all the way to the end, because then we'd be shifting zeros up, I think. So like, again, this should only iterate up to where there are no zeros, and everything up to that should shift over. Cool. Let's see what happens. Undefined. Oh, we need to return the array. That broke. So this is the expected value, and then this is what we're getting. Somehow we shifted over the 3. Let's see. up to array.length minus 0 count. And I think this for loop also only needs to go up to that because once we've reached the number of zeros, then we should stop shifting. Okay, that made it worse. I do want to do minus 1. Minus 1. Okay, but for whatever reason, we lost the 3. We're just not shifting that over. I guess one thing is, what if, okay, so check this out. So here's basically what we're doing. We found the 0, we're shifting everything one over, and then putting whatever was at the end and making that a 0. Cool. But I will increase, and that is 0. I think what we need to do is decrement I, because we just shifted everything over. We want to check that value that we just shifted over. So if we say I minus, well, no. Oh! We need to increment outside of this for loop also. Yeah, because this does the shifting, and then we increment the 0 count. Okay, so lots of weird things were happening. Hey! That did it. Okay. Lots of weird logic here. Let's run it and see if it works on Code Wars, and then we'll break it down and talk about what's happening. Oop. Sample tests. Expected 121131 instead got 121130. But my example's not doing that. Okay, let's see. Do we want to go array length minus 1 here? That still worked. I feel like I've been going at this over an hour now. Now I'm just like plugging things into it. If this works, I'm just going to submit it because I do have 2 more katas that I want to do. So let's see. No. We are missing that last value. Okay, I'm going to stop messing with this one because I want to move on. But I did create a cool solution there. This one's nice. It just creates a new array. I'll maybe revisit this one in a future episode, but basically I was trying to do it in place instead of creating a new array and like shifting the values over, but oh well, I think this one works. Submit final. Yeah, my streaming PC is really loud. You might be able to hear it. You know what? The stream will be right back. I'm just going to do some things on my streaming computer real quick, but it will be right back. Right back. Stay where you are. Right back. Okay, I am back. Hopefully I didn't lose you. All right, just a second. Pull up the chat. Yeah, my computer's working really hard for whatever reason. You might be able to hear the fan. Cool. All right, so this next kata, and if you are watching live, let me know if everything still looks good. I believe the stream should have resumed, but let me know if not. All right, this is an interesting one. It's like functional programming. So it's called calculating with functions. This time we want to write calculations using functions and get the results. Let's have a look at some examples. So for example, you say 7 invoked with times invoked with 5 must return 35. 4 plus 9 must return 13. So it's like nesting functions that ultimately will actually return the result of calculating those things. Thanks, James. Says it looks good. All right. There must be a function for each number. It looks like they have those built out for us. Each calculation consists of exactly one operation and 2 numbers. The most outer function represents the left operand. The most inner function represents the right operand. So right operand is the inner one, so it'd be 7 times 5. So left is 7, right is 5. 4 plus 9 would be 4 plus 9. That's the inner one. Okay, let's see how we might do this. Okay, ultimately, this operator function needs to hold on to or keep track of this inner number, right? So let's start by just returning that number from these functions, right? So if this function oh yeah, let's just do that. So let's just return the number itself inside of that function. Take a quick stretch, but I am ready to code this. Okay. So yeah, by default, let's just return the function. And actually, I want to pull this down because I want to use fat arrows. And I can do like a quick find and replace. So, oh yeah, let me add a note on that one. If you had been watching, I failed horribly on this last one. I tried to do it in place. I did have a working solution, but I'll just add a note. Not working right now. All right. Let's create a new file. This will be called calculating with functions. With functions. Cool. That's what we want to do. And I think it tried to auto format some stuff. Okay, cool. Let's turn these into fat arrows. Just because it'll be like much shorter syntax. So this should be const, jump over the word, equals that fat arrow, and then some function body. Okay. So my initial thought was, let's just make these functions return their values themselves. So this function should return 0. This function should return 1. This function should return 2. This function should return 3, 4, 5, 6, 7, 8, 9. Okay. And you'll notice that the operator functions take in a number. So let's just write that as their param. So it takes in number. So this invoked right now just returns 5, and so if we invoke times with 5, and let's kind of like break this down one step at a time. So right now our 5 function is literally returning the value 5, and so now when we invoke times, we're actually passing a number into it. So this makes sense that these take in a number, but what should they return? They should return a function. Because you'll notice, well, and I guess I didn't think about this before. So when it's being invoked inside of an operation, there is no parameter. But when it's being invoked with an operation, there is a parameter to these functions. So we could have some logic in there. If a number function was invoked with an operation, return a function invocation. If not, return the number itself. I think this makes sense. Okay, so let's say like operation. And if there was no operation, then return the number itself. Otherwise, invoke the operation with the number. I think. We'll see. So, and if we look back at what this looked like, if there was, so in this case, we're invoking 5, or this could be any other number. We're invoking it without an operation. So if there was no operation, just return the number itself. And then we're passing the number into the operation. Cool. But if we invoke the number with a, whatever this returns, and I'm thinking it should return a function, then we need to invoke that function. Blowing my own mind, but let's fix this for the rest of these number functions. So this should be 1 and 1. We probably could, like, I don't know, create an array of words and numbers and then just make these automatically, but I think the tests actually want these functions to exist in the test scope or the global scope. So this is 5, 5, 6. We're getting there. 6, 7, 7, 8, 8, and lastly 9. Okay, so if we're invoking the operation, let's figure out what this thing needs to actually return. So it gets in a number. It ultimately needs to return a function that takes in another number, because that's what we're passing in here. And this needs to return, if we think back, the left-hand operand, this is going to be the other number, performed with the right number. Not performed, operated on, operated with. So this function returns a function that takes in a single number like this, but when invoked will return the operation itself. That is some functional stuff. All right, and now this will be minus, this will be times, and this will be division. I think that'll do it. Let's test it out. So if we were to log 7 times 5, we should get 35. So let's try it. My goodness, we've done this is ridiculous. Okay, let's try all of these. Let's wrap this in a, oh, my keyboard was typing in the wrong place. This should be wrapped in a console.log, and this should be wrapped in a console.log, and this one also. And this one also. And this should return 35. This should return 13. This should return 5. And this should return 3. Let's see what we get. That's too cool. So the inner function, if invoked without any arguments, will just return the number itself. Because like this would return 5. And so now, basically this is a closure. Now the operation function remembers what number is because it's closed over that. And then the operation itself returns a function that takes in some other number and will actually return the operation on that. So because this returns a function, we then invoke that function inside of the number itself with the number itself. Wow. Okay. Let's try it. I wonder if it's going to be okay with my fat arrow functions. Let's see. Sample tests. Yeah, attempt. Whoa, okay. Drum roll, please. More drum roll. Wow. All right, let's see what other people did. Okay, yeah, so they did a closure. And that makes, yeah, so instead of writing it over and over again like I did, that would have made sense. Create a function that returns that thing or that function with just the value itself. That would have made sense. Yeah, and then you have your right and left values. Cool, and this is what I was mentioning before, like we could create an array of actual numbers, like words of the number, and then automatically create these functions. Yeah, and they're putting it on this, so that would put it in the, I guess, the current scope. Cool. Yeah, so this person was about as verbose as I was, but without using fat arrows. Awesome. All right, last one of the night. This one is 4Q, reverse Polish notation calculator. Let me close out of all this other stuff. Okay. Your job is to create a calculator which evaluates expressions in reverse Polish notation. For example, expression 5, 1, 2 plus 4 times plus 3 minus, which is equivalent to 5 plus, and then in parentheses 1 plus 2 times 4 minus 3 in normal notation should evaluate to 14. Note that for simplicity, you may assume that there are always spaces between numbers and operations. Expression is valid, but 1, 3 plus isn't valid. An empty expression should evaluate to 0. You may assume that there won't be exceptional situations like stack underflow or division by 0. Okay. Rodrigo, welcome to the stream. He said, thanks YouTube for not displaying when I was live. I have a similar issue. So like when I try to watch other live people on YouTube, like I set reminder or like let me know when this person is live, and it never sends me a notification. I don't know what's up. Okay, this one is going to be tricky, but before I dive into it, let's actually read about reverse Polish notation on Wikipedia, because there's actually a pretty simple algorithm. Like initially, like when I was looking at this, it can be kind of hard to figure out like how would you go from this to like order of operations wrapped in parentheses calculation. But on Wikipedia, they do have the postfix evaluation algorithm, which seems pretty simple to implement. So for each token in the postfix expression, if the token is an operator, pop the 2 operands from the stack. So the idea is we're keeping track of the numbers in a stack, and the result is evaluated using the 2 operands and whatever the current operator is, like plus, minus, subtraction, division, and then you push that result back onto the stack. If a token is a number or an operand, push it into the stack. And then lastly, you pop off the value from the stack, and that is your resulting value. We're going to use this algorithm. I do want to do like a quick whiteboard demonstration to show like what this is actually doing. But let's copy this pseudocode. And yeah, let me go to my whiteboard. I need to copy this example real quick, then I'll go to the whiteboard. So input is string with 5, 1, 2, plus 4 times plus 3 minus. That is our input string. 5, 1, 2, plus 4 times plus 3 minus. Okay. Okay, so here's the idea. If you're not familiar with a stack, the idea of it is first in, last out. So you can push things onto the stack, and the algorithm says when you come across a number, push it onto the stack. So the way a stack works is when you push, it puts the value onto the stack. And so we'll push that onto the stack, then we come across 1, we'll push that onto the stack, and we're like stacking up the numbers. And then we come across 2, and we'll push that onto our stack. And then we come across an operand. Well, an operator. Sorry, these are operands, that's an operator. And what it tells us to do is to pop off the last 2 values, and those are your the left and right operand to perform with that specific operation. So if we pop off 2, so we'll pop that off, that's going to be our right operand. And then once we pop off 2, we will pop off 1, and that's going to be our left operand, and then we perform the operation with those 2 numbers. So we popped off 1. Now our stack just has 5 in it, but we do 1 plus 2, that is 3, and then we take this result and then push that onto the stack. So now our stack has 3 and 5. Then we come across another operator. So we come across an operand, so we push it onto the stack. We then come across an operator, so we pop off the 2 values. So our right value is going to be 4, and our left value is going to be 3, and we're going to perform a multiplication. So we just popped these 2 values off. 3 times 4 is 12, and so then we'll push 12 onto the stack. And then we come across another operand, so we need to pop off 2 values. So we're going to pop off 12, that's going to be our right value, and we pop off 5, so that's our left value, and we add those together. So right now our stack is totally empty. 5 plus 12 is 17. We then push that onto the stack, so now our stack has 17 in it. And then we come across a 3, so we push that into the stack, and then we come across our very last operator, subtraction. So this is going to be pop these 2 things off, so we have 3 and then 17 minus 3. So 17 minus 3, 17, 16, 15, 14 is 14. We then push that back onto the stack, and then we've reached the end of our input. So we, I guess you can't read that. This is 14 inside of the stack. But we reached the end of the input, so we pop off this value, and then the result of the whole operation is 14. Did I get that right? Let's see. 14. Cool. So by following that simple algorithm, we can basically take something formatted like this and perform this operation, like using order of operations to get the final result. Cool. That was fun. All right, let's write the code. Okay. Yeah. Enhance. And actually, we'll show like our sample input, because we could just iterate over it as a string. I think it'll be it'll make our lives easier if we split the string on a space and like iterate over an array. So let's do that. So an example input is this. So let's convert it to an array. So let's call input. We're going to say expression dot split on space. So now we have an array of each of the values in the input, and then we'll implement this pseudocode. So for each token in the postfix operator, so we need to iterate over the input, and then also we need a stack. And for a stack, I'm just going to use an array, because a JavaScript array has push and pop, so we can push things into an array, and then if we pop them, we get them off of the end of the array. So it'll work just like a regular stack. So let's iterate. Actually, I'm going to bring this down locally just so I can scroll a bit. New file, reverse Polish notation. Okay, so let's iterate from 0 while I is less than the input array, input.length, I++. Formatting's off a little bit. Okay. And the first thing we say is if the token is an operator, then pop off of the stack. So let's have basically some functions that perform the different operations. So let's create like an object of operations. The keys will be that specific operation, and the value will be a function. Yeah, the value will be a function that takes in two numbers and then just returns that operation performed on them. So we could have operations for plus, minus, multiplication, and division. So these are our operations, and we want the token inside of the array. So let's store that in a variable. So token is input at I. That's just the current thing inside of here. So first the first token is going to be 5, then it'll be 1, then 2. So we have the token, and we want to check, is it an operator? So we'll say if operations at token. So if there exists an operation that is the current token, then we need to do this. Pop from the stack to get operand 2. I'm going to call that right value, because remember, we first get the right value, then we get the left value. So I'll say right value will be our stack.pop. That removes the last value in the array and returns it. And then our left value will be stack.pop again. So we pop it off the stack, and then the result, evaluate the token with operand 1 and 2. So we'll say result is that specific operation. So the operation at that token invoked with the left value and the right value. So if that token was plus, we would be adding the left, right, and right value. If it was subtraction, we would be subtracting the two values. So that gets stored in result, and then we push the result back into the stack. So we'll say stack.push result. Okay. Else, if the token is an operand, push the token into the stack. So if it wasn't an operation, then we'll just say stack.push the token. And then lastly, pop from the stack to get our result. So I will say stack.pop, and that should give us back what we need. Let's test it out. So if I pass in that, the expected value is 14. And let's invoke our calc with that input string. Let's see what we get. $554. You know what's happening? Whenever we split, the fact that it's a string, whenever we invoke this, it's just concatenating the strings instead of actually performing the math. So we need to turn these into actual numbers. Lots of ways to do it. You can just use plus sign to coerce it to a number, and it works. Cool. Let's try it out. All right. Whoa. Sample tests. Expected 0 instead got nothing. Expected 3 instead got plus. Okay, so when we return the result, we also need to parse that as a number. And I think if you parse empty string as a number, it gives you 0. So that works. Hey, all right, drum roll, please. It worked. Cool. All right, let's see what other people did. So they have their operators. They're calling theirs atoms instead of tokens. If the given value is an operator, then they're popping off of their stack. Cool. Cool. So this person had operands also. They're taking the expression, splitting it on the space, and then reducing it. I think it would actually be fun to write this as a reduce. Let's see, how long have I been streaming? Close to 2 hours. I think I might call it there. Actually, no. Let's try to do it with a reduce, because that would be fun. Okay, so basically we are reducing this input to a stack, and then we pop off the single value of the stack. Right? Let's try it. So here's what we want. Oh, actually, I'll leave that. I'll write it again using a reduce right below that, so you can see both versions. Cool. So this is what we want to reduce over, and we're going to be creating the stack in our reduce. So let's say stack is our expression dot split dot reduce. We are reducing down to an array because that is our stack. And we get access to the token. So now I can put all of this code inside of the reduce. And then the last thing we need to do is return the stack from the reduce. So if operations at token, pop off the stack, perform the operation, push it in, otherwise push it in, and ultimately we're returning the stack, and then the last thing we want to, oh, so I forgot, we do need to parse that as a number. And then last thing we do is pop it off. But we could do that all in one line. Let's say that dot pop, and we want to return that parsed as a number. Hey, all right, let's try it. Yeah, it works. Okay. I like this. Oh, I guess I already submitted my solution. Let's try to submit it again. Train again. So take the input expression, split it on the empty string, reduce it down to a stack, but that stack will only have one value left in it. So pop it off, parse it as a number, and return it. Cool. Final attempt of the night. Submit final. Awesome. We did it. Okay, that is it for Code Katas. Thanks everyone for tuning in. Thanks for messaging in the chat. I will push up all of my solutions. So if you go to github.com/codinggarden/code-katas, I'll also put a link in the description. You can see my solutions to all of the katas that I solved tonight. Yeah, thanks everyone for tuning in. I'll try to, so I do this stream every Wednesday. If you visit my YouTube channel, you can see past episodes. So if you check out playlists, there is a Code Katas playlist where you can see all of my past episodes. And I do this every Wednesday at 8:20 p.m. Mountain Time. If you visit coding.garden, you can see my full streaming schedule, and this will be in your time zone. So wherever you are in the world, it'll let you know when I go live. Also on my channel page, you can set a notification for that specific live stream. Apparently, sometimes they don't work. Have a good night, Rodrigo. Thanks for tuning in. But you can do that, and the upcoming live streams will be posted here as well. Tomorrow morning, I'm going to do a morning tea stream. That's where I just talk about the latest tech and kind of browse the web. And tomorrow evening, I'm going to be doing an intro to GraphQL. So tune in for that as well. Again, thanks for everyone that tuned in. Thanks for everyone that participated in the chat. And I will see you next time. Here's this.